Hello, welcome to all in our afternoon session. Am I audible? Okay, thank you, Jyoti. Actually, see, this minor change is there because as there is no class on the Sunday, on the 21st, so that's why that 4 hours, see, that's why we had shifted it. So today, what we are basically covering some, cover the some part, which is the problem part, and then remaining part we will try to cover tomorrow, so that. So before taking to the new things, so I hope see you would uh, search the answer what I have asked you, that what is basically the frequency. So before going to it, I think you can take up some numerical problems so that you may. So please feel free, even if you whatever you understand, that's not an issue. Because as soon as you interact it, it's far easier for me to deliver the content. Otherwise, going through the slides is one part, but making it understand is another part. The frequency, I basically tell you, the frequency when we are discussing this part, see the low pass filter and the high pass filter. See, for example, see where does this frequency, see frequency basically refers to basically the change in that pixel intensity. It is referred to the change in frequency, and if there is a mode change, if there is a quickly change in the intensity of the nearby pixel, then definitely it's a your high pass filters are required. And if there is a low changes, then it is a low pass filters are required. So what is basically frequency? Frequency refers basically to the change in the pixel intensity of the images in frequency domain. So and here it is spatial. On the spatial domain, it is pixel, but when we see the frequency in this part, whenever, so for example, I want to take up basically, I want to capture the face detail, right? Then face detail where overall the things are same means, for example, if you see the face, most of the things are same except the eye and this lips region, etc. There you need basically the high pass filter. Otherwise, to capture the other part of the face, other detail of the face, low pass filter is sufficient. So in this way, whenever we are basically capturing the any type of image, the distinction of this low pass and high pass filter makes the thing very useful. So I, instead of going the other content, I think that we can take up some problems, some numerical problems, so that you may feel more connected. I before it, if you have any questions, if at any time other than this content, you can always feel free. Let me problems for. Are you able to see the question number 31 on the screen? The change we have taken of the problem. Thank you, Jyoti. So see, what we are now we take up the actual numericals. The numericals is give you the feel that what's going on, right? So when you take up the problem that logarithmic transformation is defined as basically s equal to c log 1 plus r. What is this thing? The logarithmic transformation, if you would have seen it earlier in the beginning, uh, yesterday we covered this part after before the histogram. So see, what is this R? R is basically the initial intensity. Intensity, initial pixel intensity of the image, and S is basically the transformed intensity. And C is basically some constant, and it is assumed that R is always greater than 0. Definitely, because the R is basically the pixel intensity value, and the pixel intensity value will always between like 0 to the 255. So some image intensity matrix is given. So what is this thing? This thing is basically R is given. Now they are asking us to compute the transformed image S for the following two cases, where C equal to 1 and C equal to capital L upon log base 1 plus F. What is L basically? Where L is basically the maximum intensity value in the image. So what is any means? Now it's the time to basically revise the concept. So what do you, how can we will calculate it? So can you tell any value? Means how will we put the value? What will be this value? 110, this 90, 99, even you can tell this value. So it's almost like a hands-on session that where basically you do the thing, but here we are doing the problem so that you may also be better involved here. What do you, can you answer? Can you answer any of the pixel value? Transform the pixel value. See, is problem clear? What? What- So see, remember, whenever when we are seeing this problem, 99 is there. So when you will add up here, 99 plus 1, basically 100, right? So this is 100, and what will be the log 10 raised to the power 100? Equal to 1 for is 2.04. Yes, the people are, Sumitra has come up with some answer. Yes, very good. And what about this value? But remember, can you believe that it can be 2.04? Because pixel value, remember some of the basic rules basically. Why? Because they are all represented by the bits actually. Never ever take up in the point value. Two years after normalization. And what about the other value? Are other people able to understand how we are calculating it? For 99 half years, the value is to clear. So then is okay. See what we are doing actually here. It's not that difficult. See what we are doing. Tell you the. See, this is the thing. Here I am telling you. See, this is a just calculated Sumitra has calculated absolutely correctly. So see, what is this thing? We go to this part. See, if you go to this value, see 110 is there, 110 plus 1. So it will be 111. When you will calculate log of 10, when you will calculate it, it will come 2.0. Log 10, if you go to the last value, 120, it is 120 plus 1. It is 121, right? If you go to the last value, 90 plus 1, it is 91. It is 91 plus 1 here. It will be the 92. So in this way, see, this is basically what we have made the table, that on the R part, it is the initial value, initial pixel intensity value. On the right hand side, it is the transformed pixel value. Here we have written it. And R is basically 99 here. And so it has been written in this way. Is it okay? So then, but here is some problem at some place. Can you find out the problem? Or is it absolutely correct? Can you find out whether this solution is absolutely correct or is there anywhere problem? Yeah. So then is asked, I find out correctly, if it's not 99, so what will be the value here? Yes. So the answer will be basically yes. Why is log not up, right? So it will be log on. Only we have done it. If you see here, only it has been created on the upper part. It will be log 100, and here it value will be, and it's not approximate value. It is absolutely true only. Right? It is correct. So what we are saying here, that in this part, see, when you do the logarithmic transformation, if you recall, see, all the values has been mapped up to the same value, same output in it. So only what we are seeing, that how does this transformation take place? How does this work? What about this other one? And C equal to capital L octal 1 plus L. In this, if you take it, that C equal to what will be value of C? Remember, capital L is the maximum intensity value in the image, right? So when we are taking this one, maximum intensity value, so this is basically, there has been from 128 when we have taken it, and it is 60.6. Have you understood it? See why L is the maximum intensity value, 128 is not there. See, yes, remember, intensity, what is the possible maximum intensity value? See, what we are saying, if you see these digits can be represented by how many digits? It is basically by the 7, 127. So that's why it is there. It is because it depends upon the number of the bits actually. When we have taken it this one here, so the answer will become 60.66, and thereafter what we are doing, it is log 10 1 plus our other part is absolutely same. Other part it has been, we have solved it, and when we will multiply 60, actually other this part 2.0, so 2.0407, but we have to make it the complete value. When we make the complete value, so it will be 118, it will be 120. You can again see, check it, that all the values are within the same range, 0 to 127. Another important thing here that this mapping actually here, the new map has been shown here clearly. After rounding off, it is 124. So this is the final one. This is the final output here. So any question in this part? When we actually take up the practical problems, then we are able to really see that all the fundamentals which we have learned are going to use somewhere. Can we move further or you don't have any question? Because numerically, see, once you are able to solve the numerical, it really gives a lot of confidence and the picture begins to emerge that what is going to happen. Can we move further or any problem to any apart any participant, any issue? No, you don't need to be hesitant about any doubt. Please feel free. These are basic numericals. Once we are able to so now coming to the see another part. In another question, the power law transformation is defined as basically this one as S equal to CR. Again, see, remember one common thing that whenever we are basically solving this, whenever we are whenever we are solving this basically this power transformation, so S is basically the again the transformed value and R is basically the initial value. So here what again see there remember so what is gamma here? Gamma is given variable 0.2 and C is basically the one. Again the same input image is given. We want to see that what would be the new value. So because see then we are taking the same input image and then we are able to compare it. What is happening? What is happening at the output image? So when we take up this value equal to again we have first drawn it this one R it is equal to gamma is equal to 0.2 R this is basically 0.2 and 0.2 this value is given and thereafter 0.2 it is 2.2 again the same value and then when again check it that whether it is the greater than 2.5 less than 2.5 and accordingly we will assign the value 2 3 and this way we are able to compute the transformed pixel intensity value. Any question? This is basically the power law transform. And initially, see what happened that people had the different type of transformation. They applied means initially on the raw image, you apply the different type of transform. Are able to find out the different type of images. Idea also begin to emerge that how this transformation is working, and then people begin to apply it without any trial and error. So this is input image and this is output image, right? If you compare it with the last one, there all the values were of the two. You will see not big differences there, but still. I hope see we have done some. We have given sufficient time for the histogram for drawing the images. So can you find out the histogram for this image, for the digital image? On the one side, it is basically the you will find out unnormalized and normalized histogram. So, what will be the histogram? See, first we begin to explore that how the concept of histogram will come in this image of basically 5 by 5 pixel, basically 25 pixel value. So can anyone guess how the histogram will come in picture? So are you any ideas? Can what will be the histogram for this image? What you have to do plot for the unnormalized and normalized histogram for the following digital image. See, what do you mean by the histogram? If you recall, see, from the histogram, we record that basically it is the on the x-axis and the y-axis. What was on the x-axis? Even further decomposing the problem into a smaller and a smaller problem. We will connect to it. So Sumitra here has given the answer. So, but have you really understood about the other people? See what we are going 0 to 4 on the y-axis, 1 to 3, 6 to 1. See, first we try to know what is basically the histogram, right? So histogram, as see many people have answered it in histogram. See, what is important here that on the x-axis it is basically the pixel intensity. As from the uh, matrix, it is clear that the highest value is 6. So it will be definitely it's in the range of the 3 bits only. So 3 bits are there. So so how many levels will be there? 0 to 7, right? So on the x-axis, it is basically 0 here, 1, 2, 3, 5, 7. What will be on the your y-axis? It is basically the count that how many times it has come. 0 is basically coming 3 times, it is 4 times. What about the 1 value? It is 1, 2, 3, 4. This is also at the 4 time. What about the 2 value? 2 value again you can see it is basically the. So in this way basically you can draw the histogram and you can. So this is basically the histogram. You can see it here. This is drawn here. So you can see unnormalized histogram. Unnormalized histogram. So you again see the key to catch here that how many first of all total levels are there. For example, maximum intensity value is there, so it's clear that the total value will be between 0 to 7. And then thereafter we have drawn it. Can somebody tell that why are we counting this total number of occurrence capital N? Is it necessary because we have never ever used it? 4, 4. What about the 2? 1, 2, 3, 4, 5. So it is there. What about the 3? 3 is basically again the 3, 4, 5. 3 is also at the 5. And 3, sorry, 4, 5, 6. 6 is there. And 4 is there here. 4 is again basically the 3. 5 is 2. 6 is 1. Can somebody tell why we have calculated this value? Frequency, but see, to drawing the histogram, do we really need the frequency? In order to normalize. Yeah. So yes, so answer has been given, partial answer has been given. To normalize. So can you tell the answer of the next part? Go to our problem. Go to this problem. That normalized histogram for the following digital image. Can you calculate it? While doing the numerical thing, you begin to understand every word. That's why it's a very, very good exercise to recall everything, whatever we have discussed. What is something, isn't it? Yes, Shruti has pointed out correctly that it is basically the to calculate the normalized value. What will be the normalized histogram plot? Dividing each by value, yes, by 25. So what will you get? Yes, 0.16. See, again, now my question is here that can we really draw it? So major thing the histogram basically when you calculate it, it is the n is there, complete number is there. So can we really write it? See, these are actually the real problems. Whenever you read the theory, everything seems fine, but when you begin to apply in the practical thing. Here, see now we see it here. Remember, somebody saying that it is a normalized histogram plot. Definitely, we can do it here in this way. And when you will add up, what will be the value when you will add up here? It will add up to the one. This is so there is always basically a cross check that you can always check out that whether you are getting the correct normalized value or not. This option is not available in basically the unnormalized histogram. So this is the normalized histogram. Now see take up to the another problem that following histogram of a grayscale image is given, right? Here grayscale image, what is given here that it's of the 7 gray level and your and the number of pixels are given. Basically, what is given that histogram is given. Instead of giving the metric, they have given the histogram. So what you are saying that you need to perform the histogram stretching so that new image has a dynamic range of 0, 7. So can you do it? We what did we are you recall that we discussed the concept histogram stretching? even see when we are able to do the numerical, we are able to also solve the problems also, programming things also. So finally, we are aware about the algorithm. We are aware about the function that we need to write in our uh, program, or we can call also that function if it is already available. So how you will perform the histogram stretching? So remember, first we recall, see what was basically the histogram stretching. Histogram stretching was, if you see that, should I show you the slide of the histogram stretching? If you go. So that see we are able to absorb the concept, what we are going through. This is basically the histogram stretching. Are you able to see? Are you able to see the? Yes, this is the one. Because we want to actually apply those concepts actually. So again, we see what is this one. Histogram stretching is a process that expands the range of intensity levels in an image so that it spans the full intensity range. So that it spans the full intensity range of the display device. So what we are saying here that R1 and S1, this is the basically value. So what is transformation function? Transformation function is basically R max minus R min upon. Actually, it is basically line is missing. That is, this is upon R minus R min. And thereafter, see what happens if you really see what is actually happening. That this was actually the pattern, and it has gone into this. Earlier, the histogram was limited to this one. Now it has been stressed. So that's basically pattern has been seemed to be stressed. Why are we doing it? Again, see if you recall, see we are doing it here because it was the which term which we use. This type of image we remember contrast, brightness, low contrast. Another is high contrast. Absolutely. We want basically the high contrast image, so where the things are. So that's why see what do you mean by the see high contrast? High contrast will always be there where you are this stretching, where your histogram is stretched. This is there. So exactly see this is there when you are plotting this value from here to here. So it has been basically stretched, and this is shown here. See you see the see here original one. See, are you able to let me show you? See, you are able to see here that this is the value which was basically 84. Now it has been assigned the 0. How it has been assigned to the 0? If you will see this value, 255 upon F2 minus F1. What is this F1? F1 is basically the minimum value. This is R max minus R min. This is R min, so that's why 84 will scale to the 0. Is it understood? See, that's why people, that's how they have designed the mathematical value. Because yesterday I was not in a position that how this formula is coming. Yesterday we discussed that what happens in histogram stretching. But now we are able to understand that how this formula is working. We don't need to remember this formula. It will automatically come. What we are doing, we are basically normalizing. 255 is the highest value and we are normalizing between with the given extent of the image where R max minus R. So that's why, so everything, so it is bound to give, it is bound to start every value from 0. Is it understood? We are coming to the bit mathematics, but that is actually the core. Is everyone with me? See, you see this value. This is the one. Here, see, if you see in this formula, in this image, what is this F1? This is 84, absolutely. F2 is there. Can you tell what is this F2? Absolutely, it is 150. You see the beauty. Overall, the beauty, see what will be the value. See, when you put the 153 here, see for 84 it will be 0 and for 153 can you tell what will be the value? When you will put fxy and this value will be 153. Absolutely. So you see the beauty of this formula that whatever extent you give, it will stretch it from the initial point to the last point. And your shape, and you see the another thing, your shape remains preserved. See, two peaks are there, and this it is exactly the stretching. Your shape has not been deformed. See what a beautiful way the people have done the work. Is it making sense for you? See what I'm trying to emphasize upon. Whatever value you give, whatever value, see, it is bound to expand it from the 0 to the last value and without deforming the shape. That's why, that is the reason that it is changing the contrast. It is not altering the figure. So this is the thing. Are you with me? Because not only we have understood, see what is happening, but why it is happening. Why this formula only? See, whenever you are working, for example, whenever you are working as a research person in the image processing, these key insight will give you the confidence that how you can use the thing, how the things are happening. Ultimately, we need to find out this how. Need to understand this how. any question or any your observation. Because see, the way we people usually read it, the image processing, okay, this is this technique, this technique. That way definitely we can, but we are not going to apply the subject that way. We can apply the subject once we have understood that how. We can answer one thing that histogram stretching is good basically for image enhancement, one of the technique, etc. But what is happening in this formula and how is it happening in this formula that we are able to get to know. No more, no more any. Should we take break? I think today we have come too early, so maybe it be difficult for many people. So should we take a break? Okay, so we basically take a break. You try to take your time. Only see the purpose is that so that we to compensate that Sunday part. Sunday as it is not open, so that's why we have begun to take the things when many things are going on, etc., and we can compensate. So we take a break of uh, 15 minutes. Take your time so that when we come up, we can come up with the full participation, full seeing the concept. Even if you are not aware about the concept, please let me know. There is no problem. Never ever a problem. You are come here to learn, and I am here to basically share the thing, whatever we know, so that it can enhance your learning. Right? Take your time and without any with full participation, even if you are not clear about anything, please please acknowledge. So I come back. So what we had been discussing, we had been discussing here basically we had been basically solving the numerical problem on the histogram stretching. But before solving it, see, when we had been going through the histogram stretching, we tried to understand, see, what does it mean actually? Yes, stretching, but how is it happening? So there are two key things when we are focusing upon the histogram stretching. One thing is basically that it is stretched from 0 to 255. The important thing here, what is really that it is first value, something will come at 0 and something will come at basically 255 till the last end. Whatever be the initial shape of the histogram, it will always be there. Why it will always be there? Because see, the formula is this one. That it is equal to 255 upon f2 minus f1, where f2 is basically the maximum value of maximum intensity value present in the original image, and it is the minimum value present in the initial image. So in our case, basically it was minimum value was basically 84. As you can see here, it is starting. See, this value definitely would be the 84 here. And what about see this value? This value is basically the 153. So, this value, see this shape has been stressed to this one. And how it has become possible? It has become possible due to this mathematical formula. Because see, as we have already seen it here, that when you will put the 84 minus 84, for example, first value was basically 84. This is the present value. It, so 84 minus 84, it will be the 0. And in the last value, at the last value, when it was 153, so 153 minus 80, this is 153 minus this is 84. Here 153 minus 84. Same, it will be cross out. This will cross out, this will cross out, and it will lead to the 255. Is it understood? That's why we had been focusing upon. That this formula will always assure the range minimum value in the transformed image 0 and the maximum it is a 255. That's why uh, we had been emphasizing upon. Is it noted? Are you able to note it? See, Pravesh is asked why fxy is 153. See, fxy is, see, please note it here, Pravesh. See, fxy is 153 only in this last case, right? Fxy value, actually, see, this is the intensity value. This is the intensity value which has been basically initially it was 84 and in the last point it was 153. So what we are saying that what will be the corresponding value for 153? When we are taking that case 153, then fxy will be 153 in that case. Pravesh, is it clear? Saujanya? Not clear, then why f2 equal to 1? See, f2 is basically the maximum value. So okay, no problem. I explain it again. See, first we try to understand this. F2 is basically the this is the maximum value, and F1 is the minimum value of the pixel intensity here. See, range is 0 to 255, max min, absolutely. And this F2 is the, see this let me do it. Let me write it here. This is the R max, this is the R min. And this is the present value. This is the R, general R. So when we had been starting, so what is basically R? The R ranges from 84 to 153. So F1 is 84, right? So what is R min here? In this case, it is 84. What is R max? R max is basically 153. Now you see, is it making sense? Should be no problem. Please feel free. So what we are saying that when basically initial R, when it was 84, when we will put it in this formula, so here 84 minus 84, it will be 0. So it is 0 here. And in the last value, when it was 153, because fxy will always vary. F2 and F1 are fixed value. So what will be the value of this? Fxy in this case, in the last value, it is basically 153. So 153 minus 84. Here also divided by 153 minus 84. So both will cancel out and the final value will be 255. So is it bit clear? Okay. So not only for this case, you take any case. This is the magic of this formula. Shruti has asked something. Let me. F84 and 53, then take maximum. See, no. See, X and Y actually they are the coordinates. They are the spatial locations. Fx, y is, see, X and Y are the spatial coordinates, right? And F is basically the intensity value. So X and Y are not the 80, X is not. No, this is not so. Right. X and Y are the coordinates, and Fx, we always acting upon this F value only, this intensity value only. Only it is showing that with the image, because the image is basically varying with respect to the coordinate. It is a two-dimensional signal, X, Y. But what is very interesting to see from this formula, from this observation, from this numerical, that all the, see, that's why how this formula has been written in such a way so that it will, you whatever histogram you give, it will always stretch from 0 to 255. That's we are, and that's why it becomes the high contrast. Is it understood by all? Once you have understood the concept in this way, you will never ever forget it. You will always find it very easy to apply. You don't need to remember anything. Can you proceed further? Okay. Now we go back to the asking F2 and Fx. Like, no. See, Fx, see, F2 is the R max value. R basically is the R is basically the pixel intensity values of the given image. So F2 is always, so F2 is the maximum value. Since maximum value here is 153, that's why it is 153. And Fxy, that actually vary. That will vary from 84 to 153. Whenever we write anything with this function xy common, it means it is a variable. It can never ever be fixed one. But when we are writing this f2 and f1, we are not writing with respect to coordinate. That means it is a fixed value. So we go back to numerical. Here, see, we started with this problem. So now, are you able to do it? Can you? So what will we get? We will get basically when one value is given. So we will get basically the. Can you tell me what will we get? What will be the new value? If you understand, the new value will be the gray level. The gray level basically. So let's see on there. What we are saying here. So now this is the answer. So when we are saying it, it is basically as histogram is clear. It is basically the number of pixel on the y-axis. On the x-axis, it is basically the gray level. It is there. So if you see the image here, it is basically starting from the 2 to 6. But the new image will stretch from the 0 to 7. What will change? This number of pixel will change. When we see it here, so this is the formula. Is it understood? So 7 minus 0. Now see, we will take each R one by one, right? When we take each R by one, so this is here 2. So when we will put it 2, output will be 0. This is 3, it will be 2, 4, 5, 7. So this will be the basically this will be the new histogram. Is it making sense? We have done the new problem. What is important here that it has stress from 0 to 7. Earlier you histogram you see that was only beginning from 2 to 6. Now I think you can solve any histogram stretching problem. Because once we are clear, see what we are giving and what operation is happening, things are very easy to execute. But most of the times we do not realize it. We remain fixed in the formula, etc. Then it becomes difficult. That's why we have kept up a special numerical session. Can we proceed further? Or if you have any doubts, please ask it. Because one numerical is sufficient if you have understood it at the root. Take up the another one. Okay. Consider the following 5 by 5 grayscale image. Perform histogram stretching so that the output image spans the full gray level 0 to 7. Can you solve it? Here it is 5 by 5 1. 5 by 5 it is 25 pixels. Can you find out it? So if I draw it, so it is starting basically from the 1, thereafter 2, thereafter 3, thereafter it is 4, thereafter it is 5, it is 6, even it is 0 is also here. And even 7 is there, but 7 value is not present. Can you plot a histogram for it? What will be the value? How many zeros are there? 0, absolutely. So it is 0. And what about 1? It is 3. What about 2? It is 5, absolutely. See, 4, let me check it. 1 in first row 1, in second row it is 2, it is 3, it is 4, it is 5. Absolutely. 3, so then already forecasted it. It is 5. Let me check. Now everyone is confident. 3 कितने हैं? First row में 1 है, 2, 3, 4, 5. Perfect. Now see everyone is perfect. 4 is also 5. Absolutely. What about 5? 5 is basically 4. Okay. Perfect. Very good. Everyone is up to the mark. What about 6? 6 is 3. Very good. Now you all people are able to do it. So this is the thing. And what about 7? 7 is 0. Absolutely. Remember one basic thumb rule that histogram stretching will be applied only and only when 0, last 0 and 7 are not means the minimum value and maximum value are not included. That's why this is clear. So now we have to find out. So again we apply the same formula. It is what is the formula? It is R minus R min R max R min. This is multiplied by 255. See, this will 255 or something other. 7, absolutely correct. Because remember, it was basically the highest value. It is a 7 only. Now, see, once you have understood it, then you automatically get to know that whether 255, 7, etc. Now you calculate the value. So what will be the value of this 1? What is R max and R min here? R max is from the diagram, it is 6. Very good. R min perfect. Now you people are very good. Now I think you are. This is 1. So now what would the value of this 1? It will be 0. It will stress to 0. And this 7 will be stressed, 6 will be stressed to 7. And minimum is, yes, no, minimum, see, if you see in this one, here the minimum, you have to see here in this minimum. It is 1 only. Now we have to draw the plot. So what will we do? तो ये हमने वैल्यू कैलकुलेट कर ली. इससे हमें क्या आ गया? इससे हमें तो 1 हमारा क्या हो गया? अब हम कैसे कैलकुलेट करेंगे कि 1 हमारा क्या हो गया? 1 हमारा 0 हो गया. और 2 हमारा क्या हो गया? कैन यू कैलकुलेट? अब पूरा एक बार कैलकुलेट कर लेते हैं. 2 कितना हो जाएगा? 2 माइनस 1, 1/5 मल्टीप्लाई बाई 7. 1.4. Yes, able to. What about 3? हाँ, 6 minus, see, minimum will be 1 only. 3 आपने कैलकुलेट कर दिया, कितना आ रहा है? 2/5, 14/5. 4 कितना आ जाएगा? What will be the 4? Yes, 21/5. Absolutely. Or 5. Absolutely. 58/5. Very good. 6 आपका क्या आ जाएगा? 7. परफेक्ट. ये हमारे क्या हो जाएंगे? बेसिकली दिस विल बी द तो अब हमें जो वो हमारी इमेज कैसे आएगी? हिस्टोग्राम स्ट्रेचिंग में क्या होगा? हिस्टोग्राम स्ट्रेचिंग में ये होगा कि हम ये प्लॉट करेंगे. कौन सा वाला हिस्टोग्राम? जो ये नया वाला हिस्टोग्राम. नया वाला हिस्टोग्राम हम देखेंगे ये क्या है. तो ये हमारा क्या है? ये 0 है. So this is the value, right? Now we want to draw this histogram. So what is the value? 0, 1, 2, 3, 4, 5, 6, 7. So 0 is how many times it is there? 0 is basically 3 times. Are you getting it? Yeah. So I show you the answer also. So now see, you will see the problem that some values are basically 1.4. So what do? We again normalize it. It is 1. It is 3. It is 4. It is 6, 7. See, Ruth is saying something that in place of 1 there is 0. Yes, yes. In place of 1 there is 0 because see it has been actually replaced now. See, just got it right. Actually, we have not fully marked the arrow. So they are normalized or rounding. See, we are basically rounding off. For example, it is more than 0.5, then it is, and then upper integer value if it is less than 0.5. Because see, whenever you are drawing the histogram and you are plotting it, its value should be, see, you can't say that 2 is coming 1.4 times. There is no meaning. 3 is coming 2.8 times. What does it mean? So you need to go to the nearby number. So that's why we are going. You see it there. What we have done, तो ये हमने क्या कर दिया? So we have basically changed this output. We have this one. And thereafter, what will be the new image? Because finally, what we have to do? Finally, we have to uh, make the new image. How will this new image will be look like? This 5 will be replaced by the 5. This 5 will be replaced by the this 6. Right? That has been done here. 6 will replace by 7, and when you will see all these things, this has been done here. This 6 will be replaced by 7, 7. So when you will see here, so this will be the new image. 5 is replaced by 6, absolutely. 5 is replaced by 6 because it is 5.6. So that we have done here. अब आप देखेंगे see even you can calculate how many times 7 is coming. 1, 2, 3. So what is basically here, you even if you can, so 7 is basically 3 times. Which is exactly same as the 6. Is this clear? So see, what do we need to do? We have done basically histogram. See, we have done only one thing, that we have calculated basically this output value. What is in this output value? In this output value, initially it was basically this R was there. R was basically the that count. R was basically that count, and it has been replaced. This R is replaced 6 by 7, and so this is basically the new image. As soon as you will represent the new image, you will able to see the high contrast image of this. So is it understood? Right? Now you are totally understood it, how the histogram stretching is working. And you see in this new image, every value is present. 0 is present, 1 is present, 2 is not present, but all the boundaries. 2, 8 present, why not present? Yes, to see, final values are present, but it is not necessary that every value is present. 2 is not present here. See, can somebody tell why 2 is not present here? See, even in histogram stretching, we have missed some level. Yes, 7 is here. See, 7 and 0 are bound to be here. But you notice why 2 is not here. 2 is missing. Why? Even see, Mike, I repeat the question. Why 2, even in histogram stretching, 2 is not present here in this one? Is there any reason why is it so? While taking approximate value, it is not, see, absolutely. When you are taking, see, this value, because 2 has not come here. This 2 has, remember, histogram stretching implies that minimum value 0 and 7 will be there. In between value may be or may not be present. See, what do you mean by stretching? Stretching means full width will be there. But it doesn't mean that every point will be covered. That's why it has been, not only 2 is there, even 5 is also not here. Because no level has been mapped to 2 and 5. That's why. But one thing is necessary in histogram stretching, minimum value and maximum value will be present. I hope it is clear to understood by all. Can we? Yeah, thank you. Can we proceed? If you have any questions, see now you will never ever forget histogram stretching. See, this is the way. See, once you have understood the basics, as soon as you will get to know the formula or you get to know hear the histogram equalization, full picture will emerge in front of you. That how this is happening. Now, see, as you are becoming perfect in stretching. Now, come to the another problem. It is basically equalization. Suppose that a 3-bit image is there of size 64 by 64. When we are saying, we have already discussed that we specify the size of the image by the pixel. So it is 64 rows are there and 64 columns are there. It has the intensity distribution shown in the following table. So this intensity distribution. So what do you mean by say intensity distribution? See, you see the new word. Once you're able to catch the words, see, you will find the things very easy. People that don't have many things to play with. So it is like again the histogram. So what is saying basically that suppose that a 3-bit image, 3-bit image, it means what will be the range of the gray levels? It is 2 raised to the power 3, it will be equal to 8, right? 2 raised to the power 3 equal to 8. Once 8 is there, it means it is 0 to 7. So how many levels? 0, 1, 2, 3, 4, 5, 6, 7. Absolutely. So this is there. So it has size of this much. Okay. So what is this size conveying? This size is conveying, see that all the value this add up to 4096. What is it saying? That this sum 790 plus 1023 plus 850 plus 656, see this value plus 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 this value. Okay. So now actually once you are able to interpret the things, you are with the problem. This is shown. Now what has been asked here, get the histogram equalization transformation function and give the P for each K. Equalization. Are you able to remember what is equalization? No problem. If you don't know, we can go to that slide. This is the best part of the online lecture that can very easily move. This is histogram equalization, right? So that we are able to remember also. So quiz etc. will be cakewalk for you. Once you have attended these lectures carefully, the quiz etc. will be very simple one for you. So this is the histogram equalization. So see just one thing, see where does the histogram stretching fail? तभी हिस्टोग्राम इक्वलाइज्ड आया था, if you remember. तो कहाँ पे फेल, where does the histogram stretching not successful? And what is the difference? Redistributed to high intensity. See, okay. See, my question is that in which cases did the histogram stretching not successful? Uh, Blur image, okay. Contra, blur. See, blur actually is very difficult. See, we have only read the uh, contrast, bright, low contrast, and high contrast. Any answer? See, all you have read it. That's why I am expecting from you. Because the basics means you are able to play with them. Basic doesn't mean that only you recognize them. They becomes the base. You can build anything. You can build any concept to solve any type of problem. That is the basics. They becomes the base. Brightness, see, but for brightness, do you see this image? Here it is not successful. Here you have done basically histogram stretching, it has resulted into this one. Here you had done histogram equalization, it has resulted into this one. So definitely here the answer lies. Non-linear form. So non-linear, see what do you mean by non-linear? See, every pattern was non-linear, I think. That way, if you consider. I think you are not going through the slides regularly. No problem. Try to but get it. Shape is not altered in stretching. Uh, yes, yes, that is fine. See, that is basically the, yes, that's property is there. See, my question is that, see, where does the histogram stretching doesn't work? Where does histogram stretching not lead to, does not lead to the image enhancement? Not altering the contrast. See, contrast, yes, see, it is there, but see, answer actually is in front of you. That's why I feel it that you may answer. So, any last guess after a dark and bright reason? So, see, let's see. 0 and 250, absolutely. So, Sumitra, yes, patience leads to the good result. Sumitra has helped, yes. So, see, if you see it here, see what you notice here, even in the last one, that it will not be successful if my lower value, if my R min is 0 and my R max is 255. We have already seen in the last cases, in the last two example cases, that R min and R max, in the first example, the R min was 84. It was not 0. And R max was 153. And in the last example, R min was basically 1 and R max was the 6. So remember, as so this 0 means the maxima value. Maxima value and minima value, actual maxima and minima value 0 and 255 or 0 and 7 were not covered in either of the images. But in this image, in this example, if you see 0, some count is there here, frequency, and 255 has also some count. So that's why it will. So remember, then you know what will happen. In that case, he tried to understand, see, what is happening. It is 255 upon R max minus R min. Same formula, but it is a lot of information. R minus R min. Remember, as soon as here, if R max is 255 somehow, and R min is 0, then what will happen? 255 minus 0, 255 upon 255 will cancel out. So your new histograms, it will be simply a shifting. What type of shifting? See, for example, what will happen? Here, see, R is basically 0, so 0 minus 0. And what is the other value? It is basically 10. 10 minus 0, it is 10. So if you see it here, there is no change in this image. No changes, no change will take place in by the histogram stretching if your minimum and max value is this one. And people have been thinking that there is a smaller change or minor change. It is not working. It is giving the same value. Is it understood? See, that is the basically magic of the math. See, is it clear? Once if it is 0 and 255, then histogram stretching will not work. It will not lead to any change in any value. See, that's why people see usually ask me in the image processing and in the different courses, sir, is it necessary to remember the formula? See, formula is the crux. Formula is the crux of everything. It is the, you see, the in final extraction of all the things. It is such a beautiful relationship. But normally, when we don't understand it, we usually see it as some number. But see, what a beautiful thing. Once you have remembered one formula, see, even by seeing the image, people may confuse that whether it is really a histogram stretching has resulted into a some change or not desired change. It has not made any change if we are clear about the formula. So see, this is the thing. So when you are going for the engineering or you when going for the relationship, solve the numericals, solve the things. You will feel it. What I really say that words are not to feel, mathematics is to be felt. Such a beautiful relationship. All the things are confined in these 4 and 5 letters. This is the language of the mathematics. Are you with me? Some people had been saying, see, there is no change in this histogram, even it is clearly here. People had been guessing, but here there is no change is there. They are exactly same. Only the name has been changed. Only the input and histogram stretched has been written. That's why anytime, see, whenever you read any research paper or you read anything, see, definitely initially we don't understand mathematical formula in the detail, but as soon as you understand see, as soon as you initially understand, try to solve the numerical, see what is it giving. The language it is, see, remember it's all about the explanation of that simple formula. This is the thing. Are you so any question in this thing which we have discussed today? See what we are actually uh, imbibing these basics. Once you have imbibed it, see, you will never ever do anything wrong. Otherwise, and all the concepts are based upon it. How the image processing really go. That's why, see, I told you in the beginning, the purpose of this course that you are able, you have the confidence to read anything. Yes, I can read anything. It's simple. If mathematics is there, okay, let me see. We are not going to cover you every concept because its subject expands a lot, like image processing, etc., with a new problem. But I'm telling you, once you are clear about the basics, you are confident enough to read any research paper, any mathematics. Where to use stretching? See, stretching will be used where Rmax and Rmin are not 0 and 255. Even if one of the condition is not satisfied, then it will work. But if both the conditions are there, then it will not make any change, as we are seeing here. And the ideal case to use these things, how see you can easily see now. See, for example, when you will see the image, number of zero which are coming, how many dark regions are there? For example, if some image contains the dark region as well as the white region, then histogram stretching will not work. We check out our other slide. You see. Here, if you see here in this slide. Here, if you see, no more any exactly dark region is there, and nothing is basically exactly white. So I am very sure that histogram stretching will work. See the another image. Here also, if you see, all is basically the in between value of black and white. That's why here also it will work. Does it answer your question, Pravesh? Extreme, see, not actually extreme white. Yes, extreme white, or you say white is actually the 255. All are basically the extreme gray level. We call it the white, and extreme lower side of the gray is basically the black. We don't differ from the white and this extreme white. We say extreme gray because all are at the gray scale. Gray is the shade. So this thing is clear. Now this thing is clear that where we need to apply where we need to apply the histogram equalization. So now we see another thing. Now we notice again histogram equalization. What is happening here? In histogram equalization, if you see that values from the zero it has coming, and shape has also been changed. Shape has also been changed, and it has, so what has been happening? It is uniformly distributed. It has spread across it. Then increase in the dynamic range of pixel value. What is important? It is uniformly distributed. It means it is, see, it was basically the ununiform distribution. Very limited distribution. But here it is uniformly, equally distributed. Almost equally distributed. It is not flat, but uniformly distributed. What happens before solving the numerical? We want to know what do we do so that we can solve the numerical. So in histogram equalization, see, as we have seen it, so for example, some image is given. So it is given. See, again, see, this example has been given. You don't consider it as the actual image, because if you take it actual image, then here you can apply the histogram stretching also. But this is all only example to show the mathematics, right? So what has been showing here? So this has been basically, again, it is a 3-bit level. It is 4, 3, 4, 5, etc. It is there. It is gray level. The number of pixel has been shown. It is 6, 14, 5, 6, 14, 5. That is fine. Now, see, what do we want to do? In histogram equalization, we want to know the new values, new gray level for it. That is clear. See, all these are part of the different transformation operation, right? Whether it is anything, whether it is the logarithmic power transformation, or whether it is the gamma scale transformation, only we are doing one thing, that this gray level will change to the some another gray level. That is the thing. So how we need to do it? Now we go to its mathematics. What is this thing? So gray level is given. This is 0 to 7. Number of pixel is given. Now you will able to see that in our numerical also these two values are given. and I have also calculated this capital N. Are you with me? Exactly the things which are required to calculate, they are given. It is like, yeah, perfectly simulating the hands-on session. Hands-on session with our problem set. Not basically the year, definitely not the coding hands-on session, but basically the numerical, conceptual hands-on session. So is this understood? So what is going on? Now can somebody explain to you what is going on? So what we are going here, let me see. It is basically PDF, probability distribution function. It is a number of pixel upon sum. Actually, we are normalizing it. So what we are normalizing it? It is 0 upon 25. Total value it is 0. 0 upon 25 it is 0. For second one 0 upon 25 it is 0. It is 6 upon 25 it is equal to 0.24. It is 14 upon 25 it is equal to 0.56. It is 5 upon 25 it is 0.2. 0 upon 25 is 0, it is 0. Sir, we will have practical session, great for more. Definitely, the practical, only I told you that issue is that, see, many people, when we code it, so some are simulating. Anyway, we will, let me see how we can incorporate it. But I will definitely provide you with some program so you can run it, and we will see it, what you are getting. So this is basically the PDF, right? So here, see, upon from this value, so now what will we get? This is P of K. We will calculate S of K. What is basically S of K? That is cumulative distribution function. Cumulative. So what will be this value? This value will be 0, this 0. The 0 will add up with this new value. This will lead to this value. This 0 will add up with this 0 value. This will add up again 0. Now 0 plus 0.24. This 0 plus 0.24 equal to 0.24. 0.24 plus 0.56 when we are moving in this direction. Is it understood? So this has become 0.8. Instead of 0.56, it has lead to the 0.8 value. Is it understood? So then after 0.8, see what we are doing, it is basically 0.8 plus 0.2. And what is happening in this point, 0.8 plus 0.2 is equal to, exactly, it is 1. And then 1 plus 0 equal to 0.8 plus 0.2, this is equal to 1. And thereafter, this 1 plus 0 equal to 1. And this 1 plus 0 is also equal to 1. But remember, this is not the final value which we want to replace in our image. Some more changes are required. What changes? Changes basically, we want to know that when this gray level, for example, this gray level, what will be the new value? Definitely, one thing is clear that 0.24 can't be the new value. See, 0.24 can never ever replace the 3. And even if you will do 0.24, so there is some problem, something more is required. What that more is required? So here, that's why we are multiplying by the maximum gray level. Maximum gray level is 7. So are you with me? Is it becoming too heavy today? Solving the problem? Is it becoming too heavy, Sojan? It become difficult? No, okay. So let's take a break. Because really today we are absorbing the content. Take a break of the 10 minutes. We will come back. But see the slides, see the content, be in a state that after the day you can apply it. You shouldn't think that I will read it. First, the course will be over and then I will read it and then I will apply it. You should be in a state to apply it tomorrow. Right. So we just take a break of 10 minutes so that you can come back. Thank you. So really appreciate it. I hope see it is the everyone would be liking it. But see, this is the way. So we just take a break, take your time.